exploring the intersection of resilient technology, organizations, and people. REdeploy.
I can't believe this conference is existing, and here I'm super excited. It's hard for me to overstate that. I didn't know that Paul was going to give a sort of background on resilience engineering. That really helps the slides go smoother. So I want to kick off the conference by talking about finding sources of resilience. In order to talk about that, we need to talk about complexity. Something that's really interesting about technology is that when it becomes successful in helping people do their work, helping people solve problems, it starts out with relatively narrow scope, right? Books for businesses, sharing photos with your friends, your barbecue recipes. But of course, when these tools become more popular, when they become more used, more time and effort goes into extending it and to help people in new ways, to amplify what they already have, to introduce new functionality, all of that sort of thing, evolve the way that they are, it already works to be more efficient, that sort of thing. But the difficulty is that over time, these products not only end up with new functionality, but also new risks, right, that weren't present when they were first created. So because of this, success in software systems means that they grow in complexity alongside that success. They never get simpler. Successful systems become more complex. It's actually inherent in success. You have increasing complexity because you're successful. Coping with this complexity, which comes from being successful, requires resilience. But I want to sit on this just point for a moment. So success breeds complexity. Coping with that requires resilience. Therefore, if you are successful in your business to whatever extent, it means that you already have resilience. It's what's keeping your business alive. It may not be as successful as you would like, but it is actually what is keeping your business alive. So I'm going to skip over the part where there's some, I think Paul did a great job about of giving some history about the resilience engineering community, which is a field of study and an entire community. The issue here is that you have it. It's very difficult to locate. Finding and understanding resilience is challenging, and that's what this talk is about. Finding and understanding resilience is required if you ever hope to amplify or support it explicitly. So the title of the talk, I chose this wording specifically. Finding implies that it requires effort to be found. It's not obvious. It doesn't make itself conspicuous. I'm resilient, I'm over here, this is what's happening. The question then is where to look and how to look. And that's what a lot of the rest of the talk is going to be about. So now while definitions about resilience have evolved over the years, especially in the resilience engineering community, there's still a critical core notion, concept, is that resilience, and this is really probably the most succinct description of resilience, which is sustained adaptive capacity. It's been described as being poised to adapt, or having and maintaining the potential to adapt. What sets resilience apart is that it is sustaining or maintaining this potential to adapt, especially when you cannot justify it economically. Why is it hard to justify having, building, sustaining? Well, there are a couple of other descriptions I want to call your attention to. So this is David Woods, one of the sort of the pioneers of resilience engineering. He says this. He says resilience is the ability to recognize and adapt to handle unanticipated perturbations. Another one is Jean Paris, who says a resilient system must be both prepared and be prepared to be unprepared. unforeseen, unanticipated, unexpected, and in some cases, fundamentally surprising. These are hallmarks of complex systems, and coping with this is really what makes resilience different, and it's what sets it apart. So, the good news, you already have it, right? It's actually how you're doing what you're doing. The not so great news is that you can't know what, where, and when it is without looking in particular ways. And that takes skill and effort that we're just not used to in software. Yet. So where to look? How to look? So in order for me to tell you where to look, or at least make some progress towards those questions, I need to first sort of paint a little bit of a landscape, and I'm going to walk through something that that you might remember for those who have seen either previous talks or have read the Stellar report. I'm going to run through this pretty quickly. We'll start with this description of your system, your enterprise system. And there are two parts, right? There's an above-the-line region and a below-the-line region. And so it's typically quite common to see this picture as the system. What do we see here, right? Here's the website or the service or the API or whatever that you are delivering. And all the stuff that goes in to make that work, okay? The code, the data, the network, your customers, the consumers, the users, right? That's also part of it. But we know that we can't call that the system, especially for the folks who are here in this room. We know that it's connected to a bunch of things. It's connected to all these things that you use to make that system work, right? You've got the deployment tools and monitoring tools and repos, all of that sort of thing. And you could say that this is the system because many of you spend much of your time focused on those things that are here, not just really here in that little sort of cloud. By the way, it's not a cloud. It's just a well, it's not a container, but it's a it's just a diagram. Don't get all distracted by it. But if we stay there in this sort of mental model, we don't see where real work happens. If we draw this line, we'll call this line the line of representation, right? We can see you. All of the people who are getting stuff ready to add to the system, doing the framing, all of the architectural thinking, keeping track of what the system is doing, the monitoring, right? And you'll notice in this diagram that each of these people have some sort of mental representation of what the system is. And if you notice, you'll see that none of them are the same, and this is pretty characteristic in that nobody has the same representation of what's happening below the line. So this is our model of the world as resilience engineering researchers, and it includes not just the things that are running there, but all of you and the kinds of activities that you're performing, the cognitive work that you're doing to keep that world functioning. And if we play with this a little bit more and elaborate a little bit more on it, we end up with this sort of model. This model has this line of representation going through the middle, and you interact with the world below the line via a set of representations. An important part here is that your interactions are never with the things themselves. You never actually change the system below the line. What you're doing is you're interacting with the representation. That representation is something about what's going on down below. You can think of those green things along that line of representation as the screens that you're looking at during the day. But only information that you have about the system comes via these representations. And what's significant about that, and all the activities you do, all the observing, the inferring, the anticipating, the monitoring, the reacting, modifying, has to be done via those representations. So there's a world above the line and a world below the line. And although you and we mostly talk about the world below the line as though it's very real, as though it's very concrete, that's the thing, here's the mind blower. You never get to see it. You only see it. In a real sense, there's no below the line that you can actually touch. You can touch it, but it doesn't look anything or feel anything like what you get via the representations, right? And you manipulate, that's why you have to build those mental models. You have an understanding, and that understanding is continually being recalibrated and reshaped as you get information via those representations, right? And so this work above the line is cognitive work, right? And it's taking place in individuals and collectively in teams up and down an organization. This is what makes the business work. So in other words, this bit here is what copes with and adapts to the unforeseen. And the reason why this versus software is because people have flexibility and people have adaptive capacity. They can be prepared to be unprepared. I want to make this super clear. In other words, resilience is created and sustained above the line. This is where to look. If you're talking about resilience, you're talking about cognitive work. If you're talking about software and its behavior, you're not talking about resilience. You might be talking about robustness or some other thing, but you're not talking about resilience. So sustained adaptive capacity is human performance. And by human performance, what I really mean is cognitive work. To find resilience means to find and understand cognitive work that happens to cope with unforeseen situations. That's point number one that I want to get across. Now, there are some challenges and some barriers to finding this. And the route I'm going to use, the greatest barriers to looking closely and deeply at cognitive work are what I'm calling goggles, right? That we typically don't know we have. We have a lens, and this lens is something we've developed as a community and as an industry over time to make sense. It's a coping strategy. We have these goggles for a reason. It's just not necessarily helpful when we're going to look at cognitive work. And so I'm going to tell you about two of these, sort of describe a little bit this morning. One I'll call the smoothing the messy details to fit a model goggles. Still working on the marketing. And so let me show you an example of a model. Here's a typical description. By the way, there's nothing, you don't have to read the boxes or understand what I've got up here to see where I'm going with this. This is a typical description or a model for how troubleshooting or diagnosis or debugging works, okay? What's important is not the content, but what I want you to pay attention to is, man, those boxes sure are symmetrical. They sure are crisp, right? Those lines are straight, right? This is a very neat and orderly, crisp and clean. And here's another one, and it's got some little bit of variety here. There's a conditional and maybe perhaps a little bit more elaborate. Now, I'm sure you can find many versions of this and many other models that are used to frame complex phenomena. There's Colonel Boyd's OODA loop. Here's James Reason's Swiss cheese model. Let me ask you this. Where are the people? I mean, they're incredible. I'm pretty sure that all of those angles are 90 degrees. These are really great drawings. These are models, and they might be incredible models, but they are not the thing that they are attempting to model. They're a model, right? This is a famous quote from a paper in 1979. It has a very fascinating, somewhat infamous backstory the paper does, but this idea that all models are wrong, but some are useful. The first part is what I want you to pay attention to. The latter part is certainly true, but not related to what we're talking about here, okay? The models don't tell us anything about actual work, and what they can do unwittingly in this goggle sense is bias towards cherry picking what we want to see and leave the rest on the floor, right? That messy stuff on the floor, that is what we need to understand. All of the stuff that doesn't fit neatly into those boxes, we need to understand actual work. I want to hear about how that time the CTO knew an esoteric trick, right? CTO is not supposed to have hands on keyboards, right? But this time they did. I want to know about the realization that, yes, there is actually a problem with AWS. And Lisa, that's in infrastructure, she knows somebody and she's going to call them. I want to hear the stories about how Vanessa managed to cobble together a script that pulled different data from all kinds of things to repair and reassemble accidentally deleted data before anybody found out. These don't fit in those boxes. What Jen in security does to discern normal bug behavior from what an attack looks like. The realization collectively when engineers realize that when there's issues going on with this analytics pipeline, there's actually some things that you can just turn off and it's actually not that big of a deal. And that can be really, really helpful. By the way, all of these things are, all of these scenarios come from experience in hearing real events. We need to hear about the red herrings, the rabbit holes, the unproductive threads of activity. We want to know about what sources of data or information people don't trust. Or, that is to say, trust less than other sources. How responders bring newcomers up to speed when they bring them in. Hey, we're going to need your help. What sacrifices decisions people are making, right? In a lot of, in many scenarios, you might be able to sacrifice some functionality, feature flags, turning this off, shut the whole site down. In hindsight, that may be seen as a terrible idea because, you know, lost sales and all that. But of course, maybe you did it because there was a risk of data corruption, which maybe have caused other issues. Do you have the authority? How can you assess whether you have that authority to do that, make those? How specialists in one field communicate problem solving to another, and it goes on and on and on. These are the things that don't fit in those boxes. So, next, shallow data goggles. This is a different barrier, second barrier. So here's an incident. And again, maybe armed with some models, I could say, well, I can declare, well, this must be some sort of, this must be the detection phase, and this must be the resolution phase and the diagnosis phase. And look at this, we've got some numbers. Numbers mean that, and if I can categorize things, now I've got labels. It's based, I mean, the Excel chart basically draws itself. I can plot this on numbers. I can do some statistics. I can plot this on charts, I mean. But if we were to take goggles off and look deeper, now this is data. Don't get me wrong. This is data. I'm also 5'9", and that's data about me. Not wrong. It might be less useful. What if we looked at it different? What if we looked at the incident when different people joined the response? Or more importantly, maybe when they were brought in by others, right? What might that tell us? What if we looked across what teams these were on? Maybe how long they've been at the company. That might tell us something. We don't know unless we look. It paints certainly a richer landscape than TTR is 33 minutes. Maybe we can look at other threads of activity, right? Where somebody didn't know that they were looking at a broken, used to be primary, but then the secondary was promoted to primary, Elasticsearch index, or this really important person to this expertise that they needed is in Budapest on really bad conference Wi-Fi, or these two people are spending a huge amount of time managing, the cranky CTO and some sort of board member as well as tech support, and they're also doing. This is context that isn't going to show up in that shallow data. From the research, we know that shared observations can influence other people's generative hypotheses, that influence people to investigate areas that they otherwise would not have, right? But if we could identify, oh, these are the things, this is the graph, this is the alert that told us, forget about where we've been looking. That's not this is the route. We should find a route here, right? Where did people look for signals? How did they, this is a real incident, by the way. What were the hypotheses? How many of them were productive? Which ones were productive? Which ones, and at what point was it clear that they weren't productive or productive? What hypotheses do people get stuck on? Stuck on proving, fixated. And which did they abandon? So when we look closer and more deeply, if we take off these goggles, we can see that software-generated data or tools is really only one dimension in a multi-dimensional space. We love to think about, oh, but it's Grafana, and it's Elasticsearch, and it's, you know, Nagios, or whatever, all of the various tracing or observability tools. There's data that's both pushed and pulled to an engineer, and they walk into the incident with this. New dependencies. What have been recent changes? What's been happening in the world? What's been investigated thus far? What's the status of other ongoing work? Observations and hypotheses that other people share. What do they see in the logs? Maybe the time of year, time of day of year has some meaning. Who's on vacation? Who's at a conference? Traveling? So, again, I think what we need to point out here is that this is happening for everyone, right? And of course, these various data sources, memories, contextual signals, exist for everyone who's working together to solve a problem. And exploring this is what finding cognitive work is all about. And basically, there's much more valuable and critical data to explore when we don't try to boil down an incident to shallow data. So therefore, we have to take off our goggles. The most important bit is to acknowledge that these goggles exist. We can't look at our work differently if we don't know that looking differently is possible. Now, there's a couple of real talk points here. So far, I believe that my experience in the software community is that there's not a lot of patience with looking closely and deeply in these ways. And it's possible that the reason for that is that the goggles can provide enough illusion that they're learning that venturing and developing a new skill looks like unnecessary work. I think this is reasonable. But also, the research is hard to grok, right? And it can feel a bit mind-bending. I applaud and really excited about organizations like Papers We Love that can take and have advocates who can distill what is otherwise really not accessible or possibly just too dense and abstract science writing into practical places. This is also a question that we get. What tool can I use? Right? And this should be unsurprising. We're in software, right? But this is a little bit like asking, hey, what tool do I use that will program my computers for me? So, this is going to take time, right? It's taken many years, and the reason why I think that even though this stuff is hard, and even though there's barriers, I know that this community will be able to make progress. We just need to accept that it will take time. And I'm going to point to one example of that gives me confidence that we can handle it and make progress, but also that it will take time. These are three of probably the most influential papers in distributed systems theory. It's taken many years, and the brave work of enthusiastic people in our community to make their way into mainstream understanding and practices. We have to expect that resilience engineering and cognitive work concepts are going to take the same route. We can do it, but it will take time. If you're, it's not a conference talk unless there are takeaways. And if I don't assign some reading, then that's a bummer. there's a new book called Seeking SRE, which is going to come out end of August. And my colleague, Dr. Richard Cook, and myself wrote a chapter called SRE Cognitive Work. It's related to this. I've also put together a GitHub repo and resiliencepapers.club, as far as I know from this morning, it works, is a shorter URL to that. And it's a link to resilience engineering, really seminal papers from the resilience engineering community that are accessible. They're not behind paywalls and that sort of thing. And of course, there's the Stellar Report, which if you haven't read, please do. So finally, this stuff is really new. This is really, truly new. This is not just new to software. The resilience engineering community, this is new for them. And there's many routes and opportunities that we have. And my request is for you to join me and others, well, you're already here. Some of us are dumb enough to have gotten advanced degrees in it. If you find yourself enthusiastic, pull on those threads. If you don't know which directions to go, email me or tweet me or tweet Paul or tweet Dr. Richard Cook and Dave Woods and Laura McGuire, who's going to be giving the last keynote on Friday. These are people from that community, and Nora Jones and Casey Rosenthal. This is seeing the world in a completely new way, and it's critically important to society. How we understand resilience is how we understand accidents, how we understand opportunities, and how we understand the future of our work. So let's get to the good work of asking better questions. Thanks for listening.